So for this, I used the part 2, modification part 2 that you have asked for, and I have come up with this system. This system is basically the exact same, except I have extended it down to 101 to get a more accurate answer. And I have the script assigned here to obviously go through it and do that. But if I come over here to find the probability, I have an if statement, and this is if we have a 1.2 million. Out of the ending balance, it'll output a 1, and this column, we take the output of 1s, add them together, and divide them by 100, because I'm running this 100 times to find the probability of the chance of getting a 1.2 million, which, as you can see here, is 0.23, given that our beginning balances are 12,000 and our annual contributions are 2,000. And yes, that's my exam. Hope you enjoyed. Hopefully I got a good grade. And yeah, thank you. Now when we come over here to the regression output, we're gonna write the hi-hat equation. I'm coming over here. I have my answers right here. The hi-hat equation, I keep saying hi-hat, y-hat, is adding the coefficients and their respective variable. So first we have the intercept coefficient, and then we have the household income coefficient times, obviously, the household income. And then that's going to subtract from the urban percentage coefficient times the urban percent actual number. And we'll do that for all of them, as you can see here. And on the next question was, what independent variable is most significant? Is the bachelor's degree or higher percentage, given that its p-value is indeed the lowest. Having a lower p-value shows more significance in the decision than having a higher p-value. So finding the lowest p-value, and that will become the most significant variable. The least significant variable would be unemployment, which is at this 0.017. And on to the next question would be the first estimate for 2020 Trump vote percentage. I used the equation I had up there, and I inputted the values that was asked into the equation, which these being the values as I highlight them, and that outputted a 64.57 for the estimate. And for the second one, you just go in, you change the values that were changed, and you get a different answer, which is 65 now instead. It is going to go into this box over here and check if it's a 1. If it's a 1, it will return a 1 again. It's kind of redundant, but I couldn't figure out a faster way or an easier, simpler way to figure this out. So it'll receive a 1. And then in this box over here, it will collect the sum of the 1s and divide it by how many rolls actually happened. So that will be giving the probability of rolling a 6 in total for rolling just 1 6. And then I continue that into the other boxes. So if there is a 2 in the checking box, it will receive a 1, and then again it'll come over here and divide it by 1,000, the entire sum, giving us a probability. And same with the 3. Hello, my name is Jay Spence, and I'm going to be discussing my exam module 8 questions and answers. So first up, we have the first question. Calculate the change in the present from 2016 to 2020, which I have right here. in this column is my percent change, and all of the percent changes from every year, or from every single row, every county, and they're all labeled right here. And then I have the histogram to go with it to show how often each percent or each change actually occurs. And then for the second question is to illustrate the relationship between the household income with a scatter plot, which is right here. I have the scatter plot right here with the change and the income, the votes and the income, sorry. And then the third question is also right here, where I have the scatter plot right here for the votes. And then I also have the linear equation representing the trend line between. I have the equation right here. This is the equation. And then I have the R2 value to go along with it, which is 0.016. And then the estimated percent is also right here. Now going on to the pair of sixes, I pulled that up real quick, is to find the probability of throwing one or more sixes. I have created a system here to, in my opinion, more simply check for how many sixes. So I have here, it is going to go through each box in the row. It's going to check if it has a 6. If it has a 6, it'll initial a 1 for that. And if another 6 is found, it will add those ones together to equal 2 and 3 and so on, right? So if there's 1 6, there'll be a 1 in here. But if there is 2 6s, just scroll down and probably find one, it'll show 2. And for the small chance that it shows 3, cannot find one, but if there's 3 6s, it will show 3. And then that is the checking to see how many 6s I have. And then the probability, this is the first of 2 steps to find the probability, is going